Hi viewers, welcome to Sai Praveen channel. In this video, we are going to learn about the series and parallel connections of inductors. Series and parallel connection of inductors. So here figure A shows the series connection of a inductors. Figure B shows the parallel connection of a inductors. We already discussed about the resistors. The next element is inductive element. Okay. Now, so by applying KVL to this loop, what happened? Current is I of t. So inductor opposes the sudden change in current. That means the current should be changed with respect to time. So we are going to take the time varying voltage source. Okay, time varying voltage source. We already know while discussing the inductors about the inductors. We already know what is the value of the V. According to that, V is equals to L into di by dt. So if you want to learn about this, how you get this equation, just go to our videos and see the video regarding to the inductor. Is it right? So here it is Vs of t, current is I of t, L1, L2, L3. So by applying KVL to the above circuit, then you get Vs of t is equals to L1 into di of t by dt plus L2 into di of t by dt plus L3 into di of t by dt. Is it right? Why? Because we know that V is equals to L into di by dt. So here we are taking I. You can take I of t or I, no problem. Any of the thing you can take. Let it be I of t. I. Okay. Okay. So sorry, di. Now if you take the di by dt common, if you take di by dt common, it will become L1 plus L2 plus L3. Now this L1 plus L2 plus L3 can be written as di by dt. Vs of t is equals to di by dt into L equivalent. That means inductive equivalent. L equivalent equal to L1 plus L2 plus L3. Like how? How the resistors are connected in series, the equivalent resistance is sum of the resistors present in the circuit, like that. In the series connection of an inductor, the equivalent inductance is sum of the inductors present in the circuit. So the voltage drops here is V1, V2, V3. Like how we will write for the resistors. Now coming to the parallel connection of a inductive circuit. This is the parallel connection of the inductive circuit. Now coming to this, it is a parallel circuit. Then what you are going to apply for a parallel circuit? Current law, Kirchhoff's current law. By applying KCL to the above circuit, what you get? See, I is equals to I1 plus I2 plus I3. Let it be equation number 1. Here also, so we won't write it. So you can write here Vs of t is equals to V1 plus V2 plus V3. So this is V1, this is V2 and this is V3. That means drops across the inductors which are connected in series. Now here the sum of the currents entering into the node is equals to sum of the currents leaving from the node. So by coming to the inductor element, what is the current equation? We all know that current equation I is equals to 1 by L integral 0 to t V of t dt. Is it right? 1 by L integral of 0 to t V of t dt or V dt. So now substitute this one for all the inductors. Then what happened? I1 is equals to L1 1 by L1 integral 0 to t V of t dt. We all know that the voltage across each and every inductor which are connected in parallel is same. So we are taking V of t for all the inductors I1, comma I2 equal to 1 by L2 integral 0 to t V of t dt. I3 is equals to 1 by L3 integral 0 to t V of t dt. So add all these elements, then what happen? I is equals to 1 by L1 integral 0 to t V of t dt plus 1 by L2 integral 0 to t V of t dt plus 1 by L3 integral 0 to t V of t dt. From this, if you take common term, integral 0 to t V of t dt into 1 by L1 plus 1 by L2 plus 1 by L3. Let it be equation number 2, and this one be equation number 3. So from this, I am going to write here, from this I is equals to 1 by L equivalent of integral 0 to t V of t dt. So from this you can write 1 by L equivalent equal to 1 by L1 plus 1 by L2 plus 1 by L3. This is the final inductive equivalent inductor when these are connected in parallel. So inductor and resistor both are similar to each other while coming to the connections of series and parallel. Resistors are also have the same thing. See, while the inductors are connected in series, L equivalent equal to L1 plus L2 plus L3. This is for inductive in series. Coming to the inductors in parallel, 1 by L equivalent equal to 1 by L1 plus 1 by L2 plus 1 by L3. Okay. If you want to know about, so the new viewers who are watching this video first, just if you want to know the how these equations will come, just go and check to our previous videos regarding inductor. Okay. Thanks for watching.